if f of x is square root x over x minus 4, let's find the derivative. So I'm going to change this a little bit to begin with so that my derivatives are easier to find. And so I'm going to write this as, or think of it as, x to the 1/2 all divided by x minus 4. So now I see I have that quotient rule. I can apply it pretty easily. So I'll do that. I'll take the denominator. I'm finding the derivative now, times the derivative of the numerator. Well, it's x to the 1/2, so I bring the 1/2 out in front. X to the power 1 less, 1/2 minus 1 is going to be negative 1/2. Minus the top, x to the 1/2, times the derivative of the denominator, which is just 1, all divided by the denominator squared. So that's the derivative. If you can find this expression right here, then you understand the calculus. The rest is going to be trying to simplify this to get it to maybe match the answer in the back of the book or some answer that your instructor wants. And it can be difficult because each of these represents a square root. So I'm going to show you a little trick here that makes this kind of problem easier to do. So when I look at this, what I see is the problems are the 1/2 right here, because that gives me kind of a complex fraction, a fraction over a fraction. So if I could get rid of this 1/2, and then the other problem I see, the second most important problem, is I have x to the negative 1/2. X to the 1/2, that's okay, that's square root x, but this is going to give me 1 over square root x. So again, I have that fraction that I'm looking at. So watch this, it's a little trick. Okay, I'm going to take that numerator and I'm going to get rid of the problem I see. To get rid of this 1/2, I'm going to multiply by 2. To get rid of this fractional exponent, I'm going to multiply by x to the 1/2. Because look what happens, x to the 1/2 times x to the negative 1/2, I add exponents, negative 1/2 plus 1/2 is 0, x to the 0 is 1. So I've taken care of that problem right there. Okay, if I do that to the numerator, I have to do the same thing to the denominator. Okay, so I multiply numerator and denominator by that expression. Look what happens. This is why it's easy. When I multiply this times this term right here, I have 2 times 1/2, which is 1, x to the 1/2 times x to the negative 1/2, 1. That's why I did it. So 1 times, that is this times this is 1 times this is just x minus 4. Minus, I multiply this times this, okay, I have 2 times x to the 1/2 times x to the 1/2, that's x to the 1/2 plus 1/2, which is x to the 1, which is just x. And then in the denominator I have 2x to the 1/2 times x minus 4 squared. So pretty simple really. X minus 2x is going to be negative x minus 4 over, I can write this with a square root now if I want, 2 square root x times x minus 4 squared. At least it's simpler than this, right? And I'm back to representing this with a square root, which is what my original problem had. Now, this right here may not match the answer that you have in the back of the book, but if you take that answer in the back of the book and manipulate it kind of like we did right here, you'll end up with this expression. So, are you expected to know this little trick right here, multiplying numerator and denominator by that? No, it comes with experience. With experience in working with a lot of expressions like this, you learn to do this right here. But it's not something you would just think of on your own. It's a trick. It's a trick that comes with experience. But if I think about this as what's the problem here? What's the two biggest problems? That 1/2 and that negative exponent. Multiplying by this gets rid of that. Then it seems to make a little bit more sense. But in any case, I mean, who knows? You could be in a class with an instructor where the instructor wants all the denominators rationalized. Then you've got to multiply numerator and denominator by square root x. You'll get a little different looking answer. Maybe somebody did it in a different, used a little different method of finding the derivative, so they simplify and they get something like, I think the answer in the back of the book doesn't look like this. So when you introduce these square roots, and especially when you have square roots in the denominator, your answer simplified can look a lot of different ways. So how are you doing as far as calculus goes? Well, look, if you get this right here, when you apply the quotient rule, you've got the calculus down, you're doing fine. If you understand this trick once you see it, that's great. But if you don't understand it, it confuses you. You're worried like, well, how was I expected to know that? You're not expected to know it. I'm just showing it to you right now so you can see that it's kind of an easy way to simplify these expressions once you have experience with these kind of expressions. But no, you're not expected to know it on your own. So however you do this problem, however you simplify it, just see if you can't get your answer to look like this answer or this answer to look like your answer. Because of these square roots and the quotients like this, these answers can look a lot of different ways but be exactly the same as far as what they represent. So how are you doing? If you get this, you're doing fine in calculus.